What's up, Marauders? This is video 2.8, naming inorganic compounds. I'll split this section up into three different parts. This first part is going to be about naming ionic compounds. So ions, we learned earlier, are atoms, or sometimes groups of atoms, that have gained or lost electrons and therefore have a charge. Remember, the protons are in the nucleus and they're never gained or lost. That's always going to stay the same. But things can get a charge by gaining or losing negatively charged electrons. So cations are what we call positive ions, and so they get a positive charge by losing electrons. Electrons have a negative charge, and if it loses one or two or three electrons, then it'll have more protons than electrons, and therefore a positive charge overall. Anions are the name we give negative ions, and they get a negative charge by gaining electrons. Electrons have a negative charge, and if it gets extra electrons, it will have a negative charge. So we're going to be learning how cations and anions can come together to form ionic compounds. Ionic compounds are made up of cations and anions, held together by their opposite charges. So an example would be like sodium and chloride. So sodium has a +1 charge. It got that by losing one electron. Chloride has a -1 charge. It got that by gaining one electron. And so these two have opposite charges. Therefore, they're going to be attracted to each other, and they're going to make the ionic compound NaCl, or sodium chloride, which you know as table salt. So first we're going to learn to name the ions, and then we'll use that to name ionic compounds. So we'll start with the positive ions, the cations. They're just going to have the same names as the metals they come from. So this is Na, is just sodium. And then Na with a +1 charge is called the sodium ion. So all of the metals, their names will just stay the same, and it'll just be an ion. You can tell the charge of sodium, or any of the cations, by where they are in the periodic table. So sodium's right here in group 1, and we know that everything in group 1 is always going to get a +1 charge when it forms an ion. Group 2 will get a +2 charge. Over here, +3. Then with the negative ions, -1, -2, and -3. So you can tell based on the position in the periodic table what the charge is. It's not really included in the name. For the transition metals, so that's the middle section of the periodic table, they can form various ions. So we're going to use a Roman numeral to say what the charge of the ion is. So the transition metals, again, anything here in the middle of the periodic table, their charges can vary. So we'll look at copper, for instance. Copper sometimes forms an ion with a +1 charge, so we write it out like copper, Roman numeral 1, and that means Cu with a +1 charge. Different ion that copper can also form, copper with the Roman numeral 2, is Cu, and it has a +2 charge. Okay, so those are just named, you just say the name like copper 1, copper 2, and it's telling you what the charge is. And this will only be necessary for the transition metals. With sodium, I don't need to call it sodium 1, because since sodium is not a transition metal, it always only forms ions with that +1 charge. Okay, the monatomic, so that's just single atom negatively charged ions, anions that have a negative charge are going to end in IDE. So for instance, Cl is chlorine. So when it's a neutral atom, it's just called chlorine. You see that on the periodic table. When it becomes an ion, Cl with a -1 charge, we know it's a -1 charge because of where it is on the periodic table. Group 17 always form -1 ions with a -1 charge. So chlorine, you change the ending to IDE. This ion is called chloride. All right. There's also polyatomic ions. So polyatomic ions have more than one atom within the ion, and then as a group, it's gained or lost electrons. These you need to memorize the names. So here is a list of some of the more common polyatomic ions. This is definitely not all of them, but these are some of the more common ones. There's a lot more negatively charged polyatomic ions than positive ones. And so these are ones that you should be familiar with because they come up a lot. You're going to see definitely nitrate, sulfate, chlorate. Those all come up really frequently. Hydroxide's a really common one as well. You're going to see those a lot, so those are ones that you should be familiar with. And you'll need to know those when we're trying to name the ionic compounds. One thing that makes naming the polyatomic ions, or learning their names, a little bit easier is this rule right here. So the most common polyatomic ion ends in ATE. So for instance, chlorate. Chlorate, we need to just memorize that one. There's no way around that. But chlorate is ClO3, and it has a -1 charge. So if we know chlorate, that's the most common one, then we can use these naming rules to name the other ones. So perchlorate, okay, the one that says perchlorate, has one more oxygen. Okay, so instead of ClO3 with a -1 charge, it's ClO4, still with the same -1 charge. Changing it into ITE, okay, so the ATE was the most common one, which happened to have 3 oxygens. The one that ends in ITE has one less oxygen, so ClO2, still with the -1 charge. And then hypochlorite, so that prefix hypo and the ending ITE means it lost another oxygen, so ClO with a -1 charge. You still need to memorize the ones that end in ATE, so memorize this list, but then if you know those rules, it helps you to name a few more of the polyatomic ions. All right, so formulas of ionic compounds, couple rules to know, but the charges must always add up to 0. So ionic compounds are neutral. That means that they don't have a charge. Even though they're made up of charged particles, the charges balance out and they are neutral. You need to know the charge of each ion. So you need to either memorize the polyatomic ions or look on your periodic table where they're located. And then you're going to combine the ions in the lowest ratio that will balance the charges. We'll get some practice with that in a minute. If you do have polyatomic ions and there's more than one of them, you need to have those in parentheses. All right, so examples. Magnesium chloride. So when you're trying to do this one, figure out the charge of magnesium. Okay, it's right here on the periodic table, so we know it has a +2 charge. Chloride over here in group 17, we know it has a -1 charge. So the magnesium ion is a +2, chloride is a -1. Well, if we put these together, MgCl, the charges wouldn't balance out. So what do we need? We need 2 of these chlorides to balance out with the 2 positive charges from the magnesium. So every time you have one magnesium, you're going to have to put 2 chlorides next to it to balance the charge. So that means a good formula for magnesium chloride, MgCl2. A little subscript 2 tells us we have 2 chlorides every time there's one magnesium. All right, next one, sodium sulfate. So sodium is Na, it has a +1 charge. We know that from where it is on the periodic table. Sulfate ends in ATE, so we know it's a polyatomic ion. It's one on that list that I showed you earlier that you're going to need to memorize. So it's SO4, and it has a -2 charge. All right, now look at the charges. Once we know what the 2 ions are, it's +1, -2, doesn't balance out. We're going to need additional sodiums to balance that out. So with 2 sodiums, it can balance out the charge of the sulfate. So a good formula, Na2SO4. Calcium iodide. Okay, so calcium on the periodic table, we look at it, it's right near magnesium in the same group, so it also has a +2 charge. Iodide, so it's ending in IDE, so it's just a monatomic ion, similar to chloride. Similar to chloride, it has a -1 charge. And so we need 2 of the iodides to pair up with each calcium. So CaI2. Lead-2 oxide. Okay, so the Roman numeral there is given because lead is a transition metal and it can have different charges. This one's lead-2. It doesn't mean that there's 2 leads. It means that the charge of each lead is +2. Okay, oxide comes from oxygen. So look at oxygen on the periodic table. Right here, we know that these all have a -2 charge when they form ions. So oxide is a -2 charge. This one, the charges balance out right away. So we need just 1 lead and 1 oxide. The +2 will balance out with the -2. So PbO. This one, another lead oxide, but this one has a different Roman numeral. Again, it's not telling us how many leads there are. It's not telling us how many oxygens there are. It's telling us the charge of each lead. So the Roman numeral 4, so it has a +4 charge for each lead. That means not balanced with just 1 oxygen, but if we add 2 oxides to it, then it will balance. So a good formula for lead-4 oxide would be PbO2. Okay, and then you have +4 with the lead, and you have 2 -2 charges with the oxygen balancing it out. Aluminum chromate. So aluminum has a +3 charge. We know that from its position on the periodic table. Doesn't need a Roman numeral. It's not one of the transition metals. And then chromate. Chromate is one of your polyatomic ions ending in ATE, so you need to know this one. CrO4, and you need to know the charge as well. It's a -2. All right, now we'll look at the charges. So we've got a +3 and a -2 charge. We need more negative charges, so we'll add another chromate, CrO4 -2. Now we have 3 positives, 4 negatives, still not balanced. We'll add another aluminum, and we'll add another chromate. All right, and so with 2 aluminums, that's +6 charge, and then with 3 chromates, that's 6 negative charges. So it finally balances. So a good formula for aluminum chromate, we need 2 aluminums, so Al2, and then we need 3 chromates, CrO4. Since that's a polyatomic ion, we're going to need to put parentheses around it. So you put parentheses around the chromate to show we need 3 of everything that's inside of that, those parentheses. All right, last thing, going the other way. So if we have the formula, we want to write the name. So CaCl2, this will just be called calcium, because that's the name of that metal, and then chloride. Okay, you don't need to worry about the 2. That's understood because we should know the charge of the calcium. We should know the charge of the chloride. So if we write that just as calcium chloride, we can figure out that it means CaCl2. This one, Li, is lithium. Again, it's not a transition metal, so it doesn't need a Roman numeral with it. And then CO2, oh, this should be CO3. This should be CO3. So CO3 is carbonate, and so it should be lithium carbonate. So lithium carbonate. This one, copper oxide. Okay. Here though, copper is a transition metal. So unlike calcium and lithium, the charge of copper varies. So this one we have to figure out what is the charge of this particular copper. So we know the charge of oxygen. Oxygen has a -2 charge, and if it's paired with just 1 copper, then what must the charge of this copper have been? It must have been +2, so this has to be called copper 2 oxide. It's not how many coppers we have, it's what the charge of each copper is. Here's another copper oxide. For this one, we have oxygen, and then we have 2 coppers to balance out the charge. So what must the charge of each of these coppers have been? Each of these must have been +1. And so this must be copper 1 oxide. Again, it's not telling you how many coppers you have, it's telling you the charge of each copper. Here's one with iron. And then sulfur, we change the ending to sulfide. Okay, and then we need to figure out the charge of the iron transition metal. We have 3 sulfurs, each of which has a charge of -2 based on its position in the periodic table. And then it took 2 irons to balance out the charge, so the charge of each one of these irons must have been +3. So this would be called iron 3 sulfide. Okay. Last one, CO, so this would be cobalt. And cobalt is a transition metal, and it's paired up with nitride. Okay, and then the charge of nitride we know is -3. It was paired with just 1 cobalt, so the cobalt must have had a +3 charge. So cobalt 3 nitride is the correct name for that one.